In this video, we will be discussing section 12.3, which analyzes geometric sequences and series. This begins on page 810 of your textbook. So the difference between an arithmetic and geometric sequence is that in an arithmetic sequence, we are adding a common difference or subtracting a common difference, and in geometric sequences, we are multiplying instead, and that will be called the common ratio. More formally, in a geometric sequence, the ratio is constant, and that constant ratio is called the common ratio, which will be symbolized by an R. So let's look at a couple of examples and see if we can identify a geometric sequence. In our first example, let's take a look at consecutive terms. So if I take a sub 2, 5 over 2. If I take the next two terms, a sub 3 over a sub 2, that's 18 over 10, or 9 over 5. And then if I take the next two terms, a sub 4 over a sub 3, I get 28 over 18, and then 14 over 9. Alright, and none of these are equal, so I don't have a common ratio, and this is not geometric. If I look at the next example, I would do 125 over 625, and then I do 25 over 125, and then I do 5 over 25, and last I would do 1 over 5. Alright, and these all reduce to my common ratio, which is equal to 1/5. So yes, it is geometric. Which brings us to our rule. So the rule for a geometric sequence is a sub n equals a sub 1 times r to the n minus first power. So let's go ahead and look at an example for which we need to write a rule. So example, first couple terms are 4, 20, 100, 500. Alright, so I should be able to see that from term to term I am multiplying by 5, therefore my common ratio is going to be 5, and I need to identify my first term, and that is 4, and then we're going to go ahead and write our rule. So a sub n equals 4 times 5 to the n minus first power, and that is it. Now if I were to go ahead and ask you for the 7th term, let's go ahead and look at a sub 7. Let's see if we can find it. 4 times 5 to the 7 minus 1, which is 4 times 5 to the 6th power, and this is going to end up being a pretty big number. Alright, make sure we follow our order of operations and do 5 to the 6th power first, and then multiply by 4, which equals 62,500. We could, of course, be given different pieces of information and have to solve, for example, for a sub 1 in order to write our rule. So if you want to look at those examples are present on page 811 to 812. I want to get to the sum of a finite, which means it does end. There will be a certain number of terms. Alright, the sum of a finite geometric sequence. So here is the formula for that. S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. Alright, so let's look at an example of this. So we have I equals 1 all the way to the 16th term. 4 times 3 to the I minus first power. So that means I could go about it long ways and find the first term, the second term, third term, all the way up to the 16th term, or I can use my formula. S sub n equals a sub 1, so I need to go ahead and find a sub 1. Alright, so that's going to be 4 times 3, 1 minus 1, which is equal to 4 times 3 to the 0, which is 1, which is equal to 4. Alright, so a sub 1 equals 4. And then I need to find r to the n. So we need to identify what r is. So here is r equals 3. So r to the n is going to be 3 to the 16th power because n is the term we're looking for. So we are looking for the sum of 16 terms here. Sum of 16 terms equals 4 times 1 minus 3 to the 16th power over 1 minus 3. Alright, now make sure when you are performing these operations that you are typing them all correctly, and you will get 86,093,440. Make sure to use parentheses, and if you're struggling with that, compute one piece at a time.